Here we're going to be covering Chapter 4.9 and 4.10, Quadratic Inequalities and Models. So Section 9 of Chapter 4 is titled Graph and Solve Quadratic Inequalities. Now, the form, or the standard equation for a quadratic inequality is y is less than, or it could be also less than or equal to, greater than, or greater than or equal to. For the purpose of this example, I just use less than. But so basically it is y is less than ax squared plus bx plus c. Now, if the graph is y is less than, or y is less than or equal to, the graph will look like this. So we have a dashed line for y is greater than with a graph facing up. And for a y is greater than or equal to, we have a solid facing up parabola. For a less than graph, we have a dashed downward facing parabola and a just solid line downward facing parabola for less than or equal to. Now, this isn't the whole graph. An actual graph will have an area that is shaded and an area that is unshaded, and I'm going to be explaining that next. So, how do I know where to shade? We will test a point inside the parabola to determine if it is a solution of the inequality. If it is, therefore, if it is inside the parabola, then we will shade inside. So, our graph could look like this, in which we are shading the inside. If the point is not inside this parabola or is not a solution, we will graph the outside. This is similar, of course, to quadratic inequalities that are simply y equals something, y is less than something, but it's not a parabola, so it doesn't have a squared value as its x. It could just be y is less than x, and then we'd have a line, and it'd be shaded beneath. Now we're using parabolas. So we're told to graph y is greater than x squared plus 3x minus 4. So first, let's determine the general shape of this graph. Is it going to be facing up or down, or is it going to be dashed or not? So we know that since it's greater than and is just greater than and not greater than or equal to, we're going to have a dashed parabola facing up. So this is just a general view. We don't know the vertex yet, or we don't know where to shade yet. Next, we're going to test the point 0, 0 by plugging in 0 for x. So we have y is greater than 0 squared plus 3 times 0 minus 4, and y is greater than negative 4. So this is our graph. So the inside of the parabola is the shaded area, and we have a normal parabola. So a normal parabola would just be the parent graph of y is greater than x squared, but it has been shifted to the left and down. Now, a system of quadratic inequalities is going to be similar to a system of quadratic functions, in which the shaded part that both equations share, or in this case inequalities, will be our area of solutions. So any point in there will be a solution to the system of inequalities. So we have our two inequalities here, and we can recognize the first one as our blue shaded area and our second one as our green shaded area. And we know this because, first of all, we have a solid line as our parabola. Second of all, it is less than, or it has a negative sign in front of the x squared, so it's a downward facing parabola if you remember our properties of parabolas. And the next one is simply greater than and not greater than or equal to, so it's a dashed line. And it has a positive 1 in front of the x squared. We're basically going to be applying our properties of parabolas to know how to shift this type of parent parabola, like I just talked about in the previous slide. But you can really test where each point is if you're simply graphing by plugging in our xy table. So if we have 1, what do we have here, and so on and so forth, to really test out where our points are. But rather than doing this tedious method, we can go through our steps that I went over in my previous video on how to do a parabola, which is to find the axis of symmetry and the vertex. And then this video, I'm really just talking about how we know where to shade. So for a reference on that, I would refer back to those videos. Section 10 of Chapter 4, the last section, is titled Write Quadratic Functions and Models. So our directions are to write a quadratic function for the parabola shown. And we're given 2 points, one being a random point on the parabola, which is 3, 2, and the other is the vertex, 1, negative 2. And so we want to first decide what form we're going to use out of vertex form, y-intercept form, or intercept form, and also standard form is an option. So we're going to use vertex form for this problem because we're given the vertex. So vertex form is y equals, or I can use black, y equals a x minus h squared plus k. Now we're going to plug in what we know. We know our vertex, so y equals a x minus 1 squared plus negative 2. Next, we're going to plug in our point here, 3, 2, for our x and y in the equation. So 2 equals a 3 minus 1 squared plus negative 2, or just minus 2. And we're going to solve for a. So a equals 1. So when we rewrite our equation, we have y equals, and we'll leave really nothing here because the 1 we don't need to write. So we have x minus 1 squared minus 2. And this is our function for the parabola shown. Moving on, if we're just given the x-intercepts of a parabola, so say we're given this here and we're told this point and this point, what point should we use, or what form should we use? We should use intercept form. So intercept form again is y equals a x minus p x minus q, and you'll remember all of these forms from previous chapters hopefully. And next we can plug in our points. So we have y equals a x plus 1 x minus 4. This is if we're given the points negative 1, 0. Sorry, I'll rewrite that. Negative 1, 0, and 4, 0. That's our x-intercepts, so we've plugged those in here. And now once again we're going to solve for a. So a, after simplifying, we find a is negative 1/2. So y equals negative 1/2 x plus 1 times x minus 4. This is our equation. Now we need to decide what we would do if we have 3 points. So if we have 3 points, we're going to use standard form.